Once in a while, not every time. Not every time. Welcome back to my garage. Today, one problem-free run with my home-built concepts, external scavenged brute force Nitro supercharged concept engine. First, a proper rundown of said engine though, for coherence. That 4-cell LiPo I was using to drive my ignition, which sat at 1.4 volts last time, I got that going. I don't trust it anymore, so it's sitting in my kiln in case it decides to let out the smoke. I did order replacements and they have arrived. What's really stupid though is that I do own this thing, and I could have just used that in the previous episode to power the ignition. 50cc, supercharged, externally scavenged, 2-stroke with a rotary exhaust valve. Let's start with the carburetor. It's a 35mm Tillotson diaphragm carb, modified for running alcohol fuel by competition carburetors. And the star of the show, which is this ASIN AMR 300 supercharger, a roots blower, pushing 300cc per revolution. The crankcase is not connected to the cylinder in the conventional 2-stroke manner, just used as a plenum. Doing it this way makes it easy to lube the crank. Otherwise, I would need to run a separate oiling system. 2 external transfers, one on each side of the case, connected to the cylinder with reed blocks. The transfer ports in this cylinder are almost as high as the exhaust ports. That's why those reed valves are needed. The reason for doing this is I can keep on building pressure after the conventional transfers would have been closed. From this side you can see the drive pulleys for the supercharger. You can also see how the blow-off valve dumps into the exhaust stream after the primary exhaust pipe. A rotary valve in the exhaust duct, and that's there to shut off the duct at bottom dead center and allow me to build pressure and not just blow straight through, which happens in a conventional 2-stroke. Fully open before the exhaust port cracks open and it starts closing at bottom dead center. I highly recommend you go watch my other videos in this series to see how I built this. I did build everything here myself, machined and designed everything myself to get a better understanding of what things looks like, especially what the cylinder looks like inside. Conventional 2-stroke engine. There's a few variations. I'll just draw a simple case reed induction version and I'll explain the difference between this and my brute force concept engine. Here's the cylinder. Here's the crankcase. The piston moves up and down in here. This is the exhaust duct. So this is a transfer port. Here's a reed valve. That's a one-way valve, and connected to that is the carb. Not much room for a carb here. That's the carburetor. Now, leaving the pipe and the pulses and the resonance and all that stuff out of it for now, in its simplest form, how this works is that when the piston is moving up in this direction, it creates a suction in the crankcase, creates lower pressure, and this forces mixture into the case through this one-way valve. As the piston is moving down, it creates higher pressure in the case, and this forces mixture up from the case through the transfers into the cylinder. As the piston moves up, it compresses this mixture, and after ignition, the spent gases are expelled out the exhaust port. That's a 2-stroke engine in almost its simplest form. Like piston port induction would be even simpler, but let's look at my engine. Quick addition. In that cylinder, the transfer ports are always much lower than the exhaust port. So this is the exhaust port roof. This is the transfer port roof. That's because you need to drop cylinder pressure below case pressure. The pressure coming from the crankcase down here. You have to drop the pressure in there to lower than in here before these ports open. If you don't, you will have backflow and get exhaust gases pushed into the crankcase. Now in my engine, this is not the case. So this is the exhaust duct, this is the transfer duct. It's at almost the same height. In my design, the reed valves are located here. Any backflow will stop here. A big hunkin' blower here. The blower forces mixture into the cylinder. The reed valve stops the higher pressure in the cylinder after combustion to enter this plenum, the case. There's a rotary disc valve here in the exhaust. That's fully open when that port opens, shuts off at bottom dead center. So as the piston starts moving up, this shuts off. There's plenty time for this to build pressure in here, from the blower to build pressure in here, before those transfer ports are closed, because they're almost as high as the exhaust port. And this, in theory, should produce a lot of power. We'll see. We've got this big plastic container as a coolant reservoir, running a big bilge pump as my coolant pump. Now I'm preheating coolant to 50 degrees Celsius. That's for easier starting. It's cold out here. This water was sitting at about 8 degrees before I started heating it. It's not even winter yet. We'll get much colder. On my crude test bench I have CHT, that's cylinder head temperature, and EGT, exhaust gas temperature, and a boost gauge, and an on-off switch, and a fuel valve. I'm hooking my computer up for logging RPM. This Ignitec ignition has USB connectivity. You can probably guess from all the wires, it can do much more than just control the ignition. Goal today is to get a successful run without any issues. We've had issues with the rotary exhaust valve drive. We've had issues with the blower, had to reduce the drive ratio. Had issues with all the carbon fiber nylon 3D printed parts I used, which didn't seal well. One successful run without any issues. Then we can start working on the dyno. We are going to Bonneville next year, definitely. And we need at least one engine running and powerful enough to break some records. Forgot the exhaust extraction. Yes, that's a successful run without any problems. And it sounds really cool, especially at idle. It will be sitting for a while now, so it's important we purge it with the gasoline and oil. I'm really curious to see how it behaves when I pour gasoline in here. Forgot to mention that. It's running on methanol and nitromethane. Now I need to purge it with gas and oil so that it doesn't attract moisture and rust. I'm more scared of it catching fire or exploding now on gas, because that's a much more explosive thing in air compared to the methanol and nitro, believe it or not. The plan is to run it until it just dies from being too rich. Surprised of how tolerant it was to running super rich on gasoline. We're talking probably more than 4 times the proper mixture. Consumed over half of what I poured in there for that short run there. Means it should be properly purged. Perfect. Yes, perfect ending. Perfect. A perfect comeback from last week when I got the flu and everything was shit. Perfect. See you next time.